Hello students, look there on the board. Now in this session we are going to handle the questions from the JEE Mains January 2020 from matrices and determinants, and in particular in this particular video we are going to deal with the questions from 9th January evening paper. See, look there, one question is there in this board. See, f of x is the determinant of this particular matrix. The matrix is 3 by 3 and its determinant value is the f of x. Since x is involved in the determinants, f of x is in terms of x, you will get at the end if you find out. For different values of x, you will get different results for f of x. And they are asking us to find f of 50 at the end, but this a minus 2b plus c is equals to 1 is given as a hint. So, for most of the mains questions, the question itself gives you some hints. So you need to observe the question. You need to analyze the question. See here, a minus 2b plus c is equals to 1 is given. Okay? Yeah. Now first of all, I need to find out its determinant value, and you need to name that value as f of x. After that, replace x with 50, you will get f of 50. That's usual process. But in finding its determinant value, I have different options. Either I may go with usual procedure, or I may use row operations and column operations. Here, since a minus 2b plus c, look there, a plus c minus 2b is there. A is involved in the first row, c is involved in the third row, b is involved in the second row. See, to utilize that a minus 2b plus c as 1, I can go with the row operations in calculating its determinants. And that too, I will change row 1 just by r1 plus r3 minus 2r2, because there 2b is there now, 2r2. Okay, so what I am going to do, I am going to rewrite its determinant. I am going to rewrite the elements of first row just by the sum of first row and third row minus 2 times of the second row. Right? So then therefore f of x is equals to determinant of, I am changing only the first row, second row and third row we won't change. Okay, x plus b, x plus 3, x plus 2, and here it is x plus c, x plus 4, x plus 3. That's it. Now you need to rewrite the first row. How to rewrite? Add this first and third, subtract this 2 times of the second. See, you need to just think it. Okay, for example, first come from here, x plus 1 and x plus 3. If you add, what it is, x plus 1 and x plus 3 is for sure 2x plus 4 minus 2 into r2, 2 times of x plus 2. Again it is 2x plus 4. So its value is 0. Is it clear? And now coming to this, r1 plus r3, x plus 2, x plus 4. If you add 2x plus 6 minus 2 into second row, 2 into x plus 3, that is also 2x plus 6. So that means this element is also 0. Right? And coming to here, see, add first and third, 2x plus a plus c minus 2 times of this. 2x and 2x get cancelled. A plus c minus 2b you will get, and this value is 1. Okay. In particular, I will mention for you. See, x plus a plus x plus c minus 2 times of x plus b. This result we need to write in this place. Okay. X and x 2x, and this is 2x will get cancelled. A plus c minus 2b you left, and that is 1 as given. So this is 1. So at the end, one thing is very clear. So this is 1, 0, 0, and you will get this. And now, so that this determinant value is equivalent with these two are zeros. This is equals to determinant of x plus 3, x plus 2, x plus 4, and x plus 3. Okay. Now how to find its determinant value? You need to multiply these two minus multiply these two. See, if you multiply these two, you will get that x square, plus 6x plus 9 minus, if you multiply these two, you will get that x square plus 6x plus 8. X square and 6x terms will get cancelled. At the end, you left with 1. So finally, f of x, the determinant in terms of x, if you simplify, you will get its value as 1. Okay. Once look there, to find the determinant value, since a minus 2b plus c is equals to 1 is given, use this as hint and you just apply the row operations. At the end its result is 1. So See, this f of x value is independent of x. See, x value is not involved in finding its determinant, in finding f of x. Directly we get that f of x is 1. F of x is 1 now for all the values of x. They ask us to find f of 50. F of x is equals to 1 for all x. Okay, x is not involved in this situation. If you take any value in the place of x, always you will get 1 only. So f of 50 value is also 1. At the end, your answer for this problem is what? 1. Okay. So here in finding determinant, we used what? The properties of determinants. And in particular, to apply this row operation, see a minus 2b plus c is equals to 1 is given. Use this as hint to apply this row operation, and directly you will get the value as 1. And in most of the materials, in most of the books, these type of questions are available also. Okay, and that's why again we mention it as a easy to moderate level question. Okay, we don't consider it as a difficult level, right? Yeah, just have a look, and then I will come up with the second question asked in the same paper. Okay. Now, look at the board. We have second question asked in 9th January evening paper, and this question is again from, in particularly from the system of linear equations. If you observe all the papers of this January 2020, every paper contains one question from the system of equations, okay, regarding the number of solutions, whether the number of solutions are infinite, unique, and no solution. Depending on those conditions, for sure you will get one question in the mains. Okay, so it happens in January 2020, for sure it happens in the coming mains also. Right now look there, the problem involves with three linear equations. Okay, one is 7x plus 6y minus 2z is equals to 0, other is 3x plus 4y plus 2z is equals to 0, and the third one is x minus 2y minus 6z is equals to 0. Look there, the constants are zeros in these three, so usually we call them as homogeneous equations. Okay, but see, don't bother about that. Yeah, now the problem is this system has how many solutions we need to identify. See, it may have many solutions as per the first option, it may have no solution, or it may have only trivial solutions, and it may have many solutions. Okay, yeah, trivial solution and non-trivial solution. See, if the constant terms are zeros, for sure for this type of system, for these type of homogeneous equations, x0, y0 and z0 is one solution. Replace x, y and z with zeros, surely it's see that 0 0 0 satisfies these three equations. So we have always we will have one solution for this type of system, and we call that as trivial solution. Okay, yeah, see, so for sure this has one solution. Okay, 0 0 0. So this option B, no solution option, is neglected. This is not our choice. Then coming to the third case, only trivial solution, or it may have many solutions. That's what you need to think. Okay, see, for usual, for the normal linear equations and then homogeneous linear equations. For normal linear equations, we have three options: one solution, no solution, infinite solutions. For homogeneous equations, we don't have no solution case. Always we have only two options: either one solution or infinite solutions. It depends on the value of the coefficient matrix, determinant of the coefficient matrix. So you need to consider the determinant of the coefficient matrix. See, what are the coefficients here? What? 7, 6, minus 2, and then 3, 4, 2, and then 1, minus 2, minus 6. See, you need to find its determinant value. So you can go with usual procedure, no problem. Okay. See, if this determinant is 0, it has infinite solutions. If this determinant is not equals to 0, it has only one trivial solution. Okay, that's what our case. See, if you find this determinant, okay, I am not doing now, you just do usually. I think you are all aware of finding the determinants. If you find its determinant, for sure you will get 0. Yeah, since the determinant is 0, it has many solutions. So only trivial solution option is also neglected. Then there are two choices with us. Many solutions is confirmed, and many solutions for x is equals to 2z or for y is equals to 2z. That's what we need to think, right? So finding determinant I left for you. Okay, you just find it and then you show surely you get it as 0. Since it is 0, you are able to declare that the system has infinite solutions, right? See, now it is very clear the system has infinite solutions. Okay, and at that situation, if it has infinite solutions, what is the relation between x and z and what is the relation between y and z. That's what we need to identify. See, to establish a relation between x and z, use these three equations to eliminate y. If you eliminate y, you will get a relation on x and z. And for this option, if you eliminate x, you get a relation on y and z. So you just check one option, automatically if it is true, that is the choice, other one is wrong. If that is wrong, then automatically you will get other choices right. Okay. So I am going to check the first option. Yeah, x is equals to 2z I need to establish. To establish a relation between x and z, we need to eliminate y. So how to eliminate y from the three equations? You just think about it. Okay. You say the equations as equation 1, equation 2 and equation 3. We are going to eliminate what? Y. Yeah, to eliminate y, you just think there. In the first equation 6y is there. In the third equation 2y is there. So for that, you just consider the first equation as it is. Yeah, 7x plus 6y minus 2z is equals to 0. Since my intention is to eliminate y, that's why you just multiply third equation with the 3. So 3 into third equation will give us how 3x, yeah, minus 6y minus 3 into 6 is minus 18z is equals to 0. Okay, and I just multiplied the third equation with what? 3. Okay, and now you just add. If you add, what will happen? 6y and 6y get cancelled. This is 10x minus 20z is equals to 0. And it is very clear that x is equals to 2z you get from this. So if you eliminate y, you will get a relation on x and z such that x is equals to 2z. So first option is your choice, and automatically the fourth option is a wrong one. Okay, no need to check the fourth one again, right? Yeah, see, for this problem, the given equations are homogeneous equations. First of all, you need to confirm how many solutions it has, either 1 or infinite. So for that, you just find the determinant of the coefficient matrix. Since the determinant is 0, it is very clear that the system has infinite solutions. So you need to neglect these two options. Then see, it is confirmed that the system has infinite solutions. Then in that case, we need to establish a relation on x and z as well as on y and z. So to establish relation on x and z, eliminate y. To eliminate y, you need to think in such a manner, right? Again, the question is a simple one. Okay. See, the question, some students may feel it as a easy to moderate, and some of students may feel it like a difficult one also, because we need to establish a relation, right? Yeah. So this question is from moderate to difficult level question from matrices and determinants, hospital, 9th January evening. Okay. So with this video, so we completed the questions from matrices and determinants separately for each and every paper of JEE Mains January 2020. Okay. You just go through all those videos and be confident in attempting the coming examinations. Thank you.